Narayana Gurukula, Webinar 5, General Philosophy, on 5th April 2021. What is the scientific method? Where do philosophy and science differ? How do we claim Vedanta is scientific? Today, I'll be talking about the scientific method, which is the first topic of today's webinar. I'm Shola Delip, co-founder and technical director of Deron IT and Premium Careers. So, what exactly is the scientific method? According to the Oxford Dictionary, it is a method of procedure that has characterized natural science since the 17th century, consisting in systematic observation, measurement, and experiment, and the formulation, testing, and modification of hypotheses. So, in simple terms, the scientific method is the logical steps that a scientist follow to test a hypothesis by answering specific questions about the natural world. All of us are curious. Why do birds fly? Why does it rain? Why do I tear when I cry? We are all curious about the world around us. Examples of scientific method. We apply scientific method during our daily activities. Gardening, for example. When we plant something, we use the same principles as the scientific method. You observe the surrounding and come up with a lot of questions on the soil conditions as an example, or where you should be planting a certain kind of plant, under the shade or direct sunlight. The questions that you come up with will be something that you want to know more about. In this example, from the observation, we have come up with a research question. Which type of fertilizer works the best for the plant? Then we come up with a hypothesis, which is a key component of a scientific process. It states the purpose of the experiment, the variables used, and the predicted outcome of your experiment. In this example, the hypothesis is plants grown with fertilizer A will grow the fastest. Then you conduct the experiment by planting them in 3 different pots with 3 different fertilizers. So you should develop a procedure that states very clearly how you plan to conduct your experiment. You then collect the data and analyze them and come up with the results. Results are where you report what happened in the experiment. The data is most commonly charted in graphs. Finally, you conclude that the hypothesis was proven correct. This is where the results from the experiments are analyzed and a result is reached about the hypothesis. In this case, for example, the fertilizer A grew the fastest. So if the hypothesis has all the supporting data, it's great. If it's not, the experiments will have to be repeated to improve the procedure. So what exactly is the scientific method? Scientific method is the most important part of science. It is the investigational techniques used to gain new knowledge about a subject or to amend the outdated or incorrect information or integrate new information with what was previously known. Here in this diagram, I have got the step-by-step process used for a scientific method. There are normally 6 steps. So the first step is, the very first thing is to observe and ask questions what needs answering. The question is something the scientist or future scientist will want to know the answer to. You research peer-reviewed journals and papers on the topic to get the idea about what is already there. Find out if other people have asked similar questions. Research and come up with as much information as possible. You then formulate the hypothesis. It is about speculating on what you believe will be the most probable outcome of the experiment based on the research. It is very important that the hypothesis must be testable through experiments. You then design an experiment to test your hypothesis that will help answer the question. The experiment will prove or disapprove the hypothesis. The data is then collected and recorded while conducting the experiment, which are converted to graphs that are easy to analyze and understand. Depending on the results, you may want to change your hypothesis or change the design of your testing. You may even come up with a more interesting question. This stage can be repeated as many times as necessary until you find just the right hypothesis and test method to find accurate results. You then come up with the conclusion by comparing the hypothesis to the experiment results. You then share the results with the world. Also, the other scientists should also be able to replicate the same procedure step by step to get the results. In this diagram, this flowchart shows you how to test hypotheses using experiments following the steps I explained previously. You first make observations, collect information, and ask the right questions. You then formulate a hypothesis based on the questions. Like previously explained, you design an experiment to test the hypothesis. You then conduct the experiment and observe the results. You then check if you got the expected results from the experiments and compare them. If it's not correct, you go back and either conduct the experiments again or fine-tune your hypothesis. Once you get the hypothesis correct, you draw a conclusion. You then create a report on the findings and record all independent experiments that your peers can review. Hypothesis is then accepted. Additional experiments are then conducted using the accepted hypothesis. Scientific theory could also be false. You cannot prove your theory is 100% right. All you can do is to find a lot of supporting documents to prove it could be correct. For example, if someone says a parrot can swim, you cannot prove it's false. You have not seen it swim, but if you can test all the conditions or all possible places on the planet to check if parrots anywhere can swim, maybe parrots in the outer space can swim. We don't know. So the next topic is about philosophy. Philosophy is the academic study of anything, looking at the world and giving it a meaning. The word philosophy comes from the Greek word philosophia, which means love of wisdom. So the next webinar will be on how science differs from philosophy. So on that note, I'm concluding. Thank you very much.